Guys, can you hear me? Is everything clear on your side?
Yes, sir.
I just wanted to check and confirm if you guys were able to write down that the notes that I sent in the group. If you're not able to write them, it's still fine. I just wanted to check so that I know if you'll be following or not. Because for today's lesson, I'll mostly be focusing on that image that I sent in the group. So I just wanted to check, is there someone who was able to write it down?
Yes, sir.
Okay, 100%. So, guys, in today's lesson, we'll be looking at quadratic function known as parabola. So, normally, they refer to this type of a function as a quadratic function. If you like, you can still say it's a parabola. So in today's lesson, I'm going to talk about everything that you need to know regarding a quadratic function. So please make sure that in case if you don't understand something that I explain, you can just stop me and ask a question. So in today's lesson, I'll just be explaining everything. Then we'll do one example where I show you how to use these notes to answer the questions. So a quadratic function or a parabola, it's represented by y is equals to ax squared plus bx plus c. So this is how we represent a quadratic function or a parabola. So this is the first way in which you can represent the graph. Or otherwise, it can also be represented as y is equals to a into x plus p close squared plus q. So both of these, they represent a quadratic function or a parabola. So that means in a question, they can give you the function in that form or in that format, or otherwise it can be given in that format. You just need to know that both of these equations are a representation of a quadratic formula. So now the first thing, or number one, that I want to talk about is the shape. So I want to make sure that you all understand the shapes of a parabola. So remember, guys, let me just draw a Cartesian plane over there using a different marker. So obviously these functions or these graphs are drawn on a Cartesian plane where you've got the x-axis and the y-axis. So a parabola, it could be in that shape or that shape. So it's only in two shapes. So you can have a parabola which is drawn like that. You can have a parabola which is drawn like that. You can have a parabola which is drawn like that. So what matters the most is for you to understand that in this case, you've got that type of a parabola. And again, you can have another shape where a parabola is drawn like that. A parabola which is drawn like that. It can also be drawn like that, where it doesn't touch the x-axis. Or otherwise, it can be drawn something like that. So that means you can only have a parabola which is in that shape or that shape. So guys, before I even go far, it's everything clear on your side? Are you able to hear when I explain? And again, in terms of me explaining the shape, did you all understand that part?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, 100%. So now there's something I need to explain with regards to the shape of a parabola. So they normally say for this type of a shape, that's where a is less than 0. And they normally say for a parabola of that shape, that's where a is greater than 0. So the question is, which a are they talking about? And again, what does it mean when they say a is less than 0? Which a are they talking about? And again, what do they mean when they say when a is greater than 0? So this is the part that I want to explain to you guys, and I pray that you fully understand. So I'll just give you an example. Remember, we're still on number 1 where I'm explaining the shape of a parabola. So you can either have this shape or that shape. So the a that they're talking about is that a over there from that standard equation or standard representation of a quadratic function or a parabola. So for example, if you have, let's say y is equals to 2x squared plus 3x maybe minus 4. So this is an equation, this is a quadratic equation. So we can use this quadratic equation to draw a parabola. So now I want us to talk about that a. So remember, this is a x squared plus bx plus c, whereby our a in that case is 2. I hope you know very well. And let's see, our b is 3, our c is -4. But in terms of the shape of the graph, for it to be this type of a graph is determined by that a. For it to be this type of a graph, it's determined by that a. So how does that a determine how the graph looks like? So they are saying if we have a positive a, so that's what they mean when they say that's where a is greater than 0. So for a number which is greater than 0, it means it's a positive number. So because we've got a positive a, guys, that means we are going to have a smiling shape. So it makes a perfect sense when we draw the head and make it a smiling shape. So can you see, guys, this is a smiling shape. What does it mean? It means the mood is positive. The a value is positive. So that's why we are having a smiling shape. So remember, this is where you're going to have your x-axis and your y-axis. So ladies and gentlemen, before I explain the other shape, do you all understand this part with regards to where a is greater than 0? Does it make sense to everyone?
Yes, sir, it do make sense.
Yes, sir.
Yes, sir. It do make sense.
100%. So now let me also give a different type of an example where you've got, let's say y is equals to -7x squared, let's say minus 4x plus, let's say 1 as an example. So ladies and gentlemen, in this case, can you see we've got a negative a value? In other words, it means this is where a is less than 0. So remember, guys, for a letter to be less than 0, it simply means it's a negative value. In other words, I'll just give you an example. On the number line, we've got 0 there. So we've got positive values on this side, we've got negative values on this side. So that means from there, in that direction we have negative values, from there in that direction we have positive values. So everything is referenced from that point. So that means when they say for the values where x, remember this line is the x-axis, so all the values there are the x-axis. So when they say where x is less than 0, they are talking about all the numbers in that direction, guys. So that's why we are saying from 0 in that direction, all the values are negative. You have -1, -2, -3, -million, whatever. So when we say x is greater than 0, can you see we are saying from there in that direction, that's where we have +1, +2, +million, whatever. I hope you fully understand what it means when we say where the value or the letter is less than a 0 or greater than 0. So can you see for that quadratic function, we've got a negative a value. So that a value, it doesn't matter whether it's 7 there, whether it's 10, whether it's 5, whether it's 3, 2, 1 or whatever, even if it's maybe 3/2, it doesn't matter. We are only focusing on the sign in order to determine the shape of the graph. So if, ladies and gentlemen, we've got a negative value there, that's when we are having a sad shape. Remember, this is a positive shape. This will be a negative shape. So let's just see if it makes a sad shape over there. So can you see, ladies and gentlemen, this is a sad shape. So that means I've only spoken about the sign of that a value. Someone might be asking themselves a question to say, when we talk about the a value, is it only that one on that equation? Ladies and gentlemen, an answer to that question is that it's not only that a that we are talking about. We also refer to that a. Why? Because both of this is the same thing. It's only that it's represented in different forms. So that a, for it to be negative, if that a is negative, then it means we're going to have a sad shape. Remember, this is just a shape where it's going to be drawn on a Cartesian plane. So guys, I'm not sure if so far you understood what I've explained regarding the shapes of a function.
So we understand the Cartesian.
Yes, sir, we
Good,
understand.
We do understand, sir.
Okay, 100%. So now, let's see. Let me remove all of that. I'll write it again. So initially, we had y is equals to ax² plus bx plus c, and again we had y is equals to a into what was it? Was it x minus p² plus q over there? So let's now talk about number 2. Remember, guys, I've got this notes posted in the group.
P change
Is there someone?
the sign change there because on the first lesson you said it's x plus p, but now you said it's x minus p.
Let me see. Thanks for that. I think it should be a minus. So in case if on my notes it was what was it? If it was a positive sign, let me just quickly confirm. I'll just check. Let me just quickly confirm. Then I'll let you know if you need to update those notes, because it's important that we get it right. Okay, no, it's a plus. Then it's a plus. It means whatever that we had on the notes, it's correct. So it's a plus over there. Thanks very much, whoever who made that comment. So let me do this. Okay, let me get a different marker. So guys, remember, it's a plus over there. Okay, so now let's continue. So I'm going to explain number 2, which is the axis of symmetry. Axis of symmetry. Never forget this thing, guys. Axis of symmetry. Cele, Shreyas, and Sitle. This is what you will get when you get to grade 11. You'll deal more about that. But even in grade 10, you just need to be aware of something called axis of symmetry. So remember, guys, what I'm going to be doing for today's lesson is to focus on this, which is directly for grade 11s and 12. Then as soon as we're done with the lesson, I'm going to give you some examples that you can work on to practice. In tomorrow's lesson, I'm going to focus on stuff for grade 10. I'm going to be doing the same. It's going to be a quick lesson because they've joined this lesson and their stuff is not that much. Then I think about 15 to 20 minutes we'll deal with their stuff. I'm going to give them their homework. Then on that same lesson, we'll be doing corrections of the homework that I'm going to give you guys. So in tomorrow's lessons, I'll also be expecting all grade 10s and 11. So guys, please do make sure that you don't miss any of my lessons. So guys, axis of symmetry. Let's now talk about axis of symmetry. Remember, ladies and gentlemen, at all times, we have a Cartesian plane where it has the x and the y axis. You also need to know that there at the center, you've got 0, which is called the origin, that point. So now, what I need you guys to be aware of is what we call axis of symmetry. Remember, you can either have that as your parabola, and again, you can either, let's say, have something like that as a parabola. So guys, can you see in this case you've got 2 types of functions. You've got that one which has got a smiling shape. That means the a value for that graph is positive. The a value for that one is negative because it's a sad shape. What does it mean? It means the a value is negative. So when we talk about the axis of symmetry, is that line that splits the graph into half. So can you see, guys, at the turning point of that graph, you can have that line which cuts the graph into 2 equal halves. So that means that half of the graph is the same as that side of the graph. So the axis of symmetry for that one, this is where you've got a turning point. So that means half of that graph, it's equals to that side of the graph. Let me just draw one function and explain in each case. So we've got a Cartesian plane where we've got x and y. Let's say you've got that. Then let's say from there you've got -1. Let's say 1, 2, 3. Let's say you've got 4 over there. So this is the turning point of that function. So remember, guys, obviously the turning point, that's where that graph changes direction. So can you see it has been moving like that, then this is where it turns, then it goes in that direction. That's why we say that point is what we call TP, which means is the turning point of that function. Remember, guys, in case if you've got more than one graph drawn on a Cartesian plane, that's where they give it a name. So what type of names do they normally give the functions? They can give it a name where they say is the graph of f, is the graph of g, is the graph of h, and what else. It doesn't really matter what name they used. So let's say in this case is the graph of f. So don't get confused by that letter where they say that graph is the graph of f. It means they, instead of them writing y, they write f of x. And also there, if maybe the name of that graph is g, then it means is g of x. So that means the moment you see f of x, g of x, h of x, this thing, guys, is the same as y. why do they have to choose any of those letters? Is to specify, to say that one is the graph of f, just in case if you still have a straight line. So can you see, if you have a straight line, you cannot be calling both functions as y, because we won't know which one is which one. So for us to not confuse you, we choose any letter there. So that means, guys, this is going to be your axis of symmetry. Where do you get your axis of symmetry? It's halfway between the x-intercepts. You can just add it as part of your notes. So that means axis of symmetry is halfway between your x values. So what is halfway? What is the value which is between these two x values? Is there someone who wants to give it a guess? Okay,
True, sir.
it's fine. So I'll just explain that. I'm glad you gave it a guess. So, ladies and gentlemen, halfway between these 2 points, that's where you've got the midpoint of these 2 points. So halfway, it's half of x1 plus x2. So you can punch all of this on your calculator. So that means you're going to have half of, what is x1? x1 is -1 plus what is x2 is 4. Then whatever that you get when you punch this, I think it's going to be 3/2. So that means your axis of symmetry, that's where your x value is equals to 3/2. So it seems as if I said there is 1, there is 2, there is 3, but actually my axis of symmetry was supposed to be a straight line in that direction and not cutting through that 2 over there. So let me give another example so that maybe it makes a perfect sense. So let's now have a Cartesian plane and have a parabola in that way. So a question to you guys, are we having a positive or a negative value there for this graph of G?
Negative value.
Negative value, sir.
100%. So
Negative
we're
value,
going
sir.
to have a negative A
Values.
value. So let's say we've got maybe that, and that, -1, -2, -3, -4. Let's say there we've got -4, and then there we've got what is it? No, I wanted a different value. So let me just shorten all of that and say -1, -2, -3, -4, -5, -6, -7. Let's say this is -7, 1, 2, 3, and let's say let's make it 6 there and make it 3 there. So ladies and gentlemen, if the question says what is the axis of symmetry, you just know very well that the axis of symmetry is that line that passes straight vertically upwards through the turning point, and the x value of that dotted line, which is called axis of symmetry, is halfway between the two x values. So in other words, it's more like is the midpoint of the x values. So my question to you guys, in this case, is there someone who wants to give it a guess and tell us what is the axis of symmetry? So whatever answer that you get, you're going to say x is equals to whatever number that you get.
-3/2.
-3/2, sir.
Negative
How
3/2, sir.
how do you guys
Negative
get
3/2.
how do you guys get negative 3
Negative
over
2
2?
over
So we use the
half
other teaching.
into x1 plus x2.
100%. So that means we are all on the same page regarding the axis of
Negative
symmetry.
2.
Remember, guys, you don't need to stress that much about you thinking of how a question will be asked out of these notes that I'm presenting to you guys. I'm going to teach you in detail. What I'll be doing is to solve for you exam type of questions where you have two types of graphs. They normally give a parabola, then a straight line on a Cartesian plane. So you just need to make sure that everything that I explain in today's lesson, you understand, because when I teach you how to answer exam questions, I'm going to be referring to these notes. Remember, we have done everything that you had to know regarding a straight line. So this is just an introduction. So I just want to assure you guys that it's not that much difficult to solve this type of problems. The challenge that you are having, especially when you're in matric, is because you did not have the basics, which is what I'm giving to you guys. So the moment you are confident with the basics, you will understand everything. I'm pretty much sure that we've got grade 10s learners who joined this lesson, but they are able to understand everything that I'm explaining, which is an indication that mathematics, it's not that much complicated or difficult. You just make sure that you understand and you are able to use these tools to solve for questions. So normally what they do, especially when I was in high school, our teacher would teach all of this but not take us through exam questions. So when they ask in exams, they ask questions such that we need to use all of this information, but because we were not trained to apply these tools, that's why we fail in exams. So that's why I'm saying I'm mostly interested in teaching you guys how to solve exam type of questions, because I know once you are able to solve, then you won't struggle with any type of a question. So ladies and gentlemen, let's now move to number 3. I hope everyone understood what is axis of symmetry. Remember guys, these things are in order. So when you practice, make sure that you follow the order of my notes. So now let's talk about number 3, which is TP. What is TP, guys? TP is the turning point. So let's say you've got a Cartesian plane where you've got the x and the y axis. So let's draw something similar to that. Obviously, we know our a value is going to be a negative a value. Is it the only one who can hear me, who cannot hear me clearly? The other guys, are you all able to clearly hear me?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, it's
Yes,
fine.
fine.
Whoever who's not able to clearly hear me, maybe just try to change your position. But otherwise, I've got this lesson recording. It's currently recording. I'm going to post it on my website. Then you can use it to catch up. So we'll just continue in the meantime. But just make sure that in case if you couldn't get everything, you catch up using the website. All the information will be posted there. But what you can do in the meantime, just maybe change the location wherever you are. So now, ladies and gentlemen, let's talk about the turning point. This is a function. Let's call it h of x. Remember, h of x, guys, is just the same as y. Don't get confused. This is TP. So when we talk about the turning points, guys, we want to know the coordinates of the turning point. So what I'll be teaching you is how you find the coordinates of the turning point. So you can only be able to find the coordinates of the turning point if you know your axis of symmetry. So if you know your axis of symmetry, that's when you can be able to determine the coordinates of your turning point. So I'll give an example, guys. I'll just quickly do something here. Let's say, for example, you are given a function similar to that. You've got a positive a value there. This is x-axis, this is y-axis. Remember, guys, at all times when you draw a function, you start with the axis or a Cartesian plane. So let's say this is the graph of a G. So what I want to explain to you guys is that this is the turning point, and let's say that graph, its y is equals to, let's say, positive 3 x squared, let's say minus 6x plus, no, it's going to be a negative. I know why it's going to be a negative, of which I think I'll explain at a later stage. So let's say negative 5 as an example. So can you see, guys, in this case, you are given the equation of that parabola, but you are not given the two x values. So I've already explained the first method where we say axis of symmetry is equals to half of x1 and x2, which is more like the midpoint. So it's x1 plus x2 divided by 2. So that means this is the first formula to determine your axis of symmetry. You only use that one if you know that x value there and that x value there. Otherwise, if you are not given that x value and that x value, you use a formula which says x is equals to negative b over 2a. So that means we have two ways in which we can determine the value for the axis of symmetry. So which b, which a is very, very easy, guys. Very, very easy. You know, you've got a there, b there, you've got your c there. So that means 3 is your a, that one is your b. So be careful when you substitute. You have that negative from the original formula. In brackets, substitute your b value, which is negative 2, divided by 2. What is your a value? Is 3. It's equals to. Then you can punch all of this on a calculator. I think you're going to have positive 1. So that means your axis of symmetry, you say x is equals to 1. So that is your axis of symmetry. Guys, did that make sense to everyone?
Yes, sir, it does make sense.
Yes,
Yes,
sir.
sir.
Oh
Okay,
yes.
100%. In that case, now that we know our x value for the axis of symmetry, when you calculate the y value for the axis of symmetry, so you substitute this into the original equation. Remember, guys, this is x, this is y. So you calculated x, now you want to know what is y. Then it means you're going to say y is equals to 3 into whatever axis of symmetry that you got, you substitute into the original equation. So that means you punch all of this on your calculator. Whatever that you get, it is the y value of your axis of symmetry. So I think this is 3 minus that, then it's minus 3 minus 5. I think this is minus 8. So that means your turning points, guys, is 1 and negative 8. So these are your turning points. So guys, did that make sense to everyone?
Yes, sir, it does make sense.
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, 100%. So
Yes,
now
sir.
eh, let me give the last example. After this example, we move on to the next part of our notes. So let's see. Let's say we've got a Cartesian plane over there. Then we've got something similar to that. Obviously, this is going to be the turning point. And let's say there they say this is the graph of y. Obviously, a has to be negative. Let's say it's negative let me do this and say it's negative x squared plus x, let's say, plus let's say plus 5. This is just an example, guys. So remember, guys, in this case, if you want to know what is your axis of symmetry, because you don't know those two values and you are given an equation, that means in this case you use that formula which says negative b over 2a, which is negative, your b value obviously is that invisible 1 over there divided by 2. What is your a value? It's negative 1 over there, which means negative cancels, then you have 1 times that, so you've got a what is it? Is it a negative half? Let me just confirm what are you having. So that means you're going to have your a value as positive half. Let me see. Our b value is positive 1, yes, and then our a value is that, yes. So that means to draw that function correctly, we are going to have our y-axis there. So ladies and gentlemen, did that make sense to everyone?
Sir.
Yes, sir.
Yes, sir.
Sir.
Okay, 100%. Let me now explain something regarding this type of a function. So remember, guys, we've got ax squared, let me say y is equals to ax squared plus bx plus c, and then now let me just draw something similar to that and say this is TP. We already learned that in this case we've got negative a value that we fully understand. And again, if we want the axis of symmetry for that, we're going to say x is equals to negative b over 2a. This is the formula in case we don't know those x values. So again, we know that if we want to then now calculate the y value, remember the x value is negative b over 2a. And if you want to calculate the y value, you substitute this into the original equation. Let's say this was the graph of g. So that means you're going to say g of negative 2 negative b over 2a. So this thing, guys, don't get confused by this thing. It's not that much complicated. It simply means that when you use this formula, you obviously get an x value, of which we firstly called it as, let's say, 3 over 2. So this is the x value for your axis of symmetry, which means maybe its x is 3 over 2. Then when you calculate the y value, what do? You just substitute this into the original formula where you get x. So that means in that case, there you're going to substitute your x value, there you're going to substitute f. So this thing which says g of negative b over 2a, don't get confused by this thing. Remember, this thing is the same as g of x. So that means in place of x, you substitute whatever answer that you got when you calculated your axis of symmetry. Then in that way, you are going to find your y value. So what is that y value? That y value is this one, guys. This is the y value, because obviously we need the x value, which is 3 over 2. The corresponding y value, it's going to be that one over there. Then that's how you get the coordinates of the turning point. Guys, did that make sense to everyone?
Yes, it did make sense, but some I didn't understand.
Sir, I am lost.
You are lost. Do you
Yeah, I'm very,
guys?
very lost.
Okay, let me try to explain again. Let's say we've got this. Let's say there we've got that. Obviously, this is y, this is x. So let's say the equation for that function is y is equals to, obviously, let's say it's negative maybe 2x squared, let's just say plus 4x. This is just an example, guys. Let's say plus 4 over there. So do you guys agree that for us to find the turning points, firstly we need the axis of symmetry, and you do know how to calculate this one, which is x is equals to negative b over what is it, 2a. So let's calculate the axis of symmetry. What is the axis of symmetry, guys? Anyone who got the answer?
It's 1, sir. The answer is
So
1.
1, sir.
I'm also getting 1, which means x is equals to 1. So that means that point there, we already know that x is equals to 1, which is that point there. It's equals to 1. Do you all understand and agree with me based on what I've explained so far?
Yes, it's one I do understand, sir.
100%.
Yes, sir.
So now, what confused you when I was explaining? It's how to find the value of y. So I'll just make it simple, then we won't have to go deep with that information because it might be a bit confusing. But once you get used to them, I will re-explain it again at a later stage. You will now understand. Even when I explain this, you might understand. So now that we already have the x value, for you to find the y value, you use that same equation. Where you see x, you substitute y. So the value that you get is the corresponding y value at that point over there. So since we know that x there is 1, the question is, what is y over there? This is what you're going to calculate. So it's going to be negative 2. What is your x value? Plus 4. What is your x value? Plus 4 over there. So that means because your axis of symmetry is 1, if you substitute 1 there where you see x and punch all of this on a calculator, it's going to give you the y value where x is 1. I'm not sure if it makes sense before you guys give me an answer. Does it make sense?
Yes, sir.
Yes, sir.
Yes, sir. Yeah, I think the answer is 6.
So that means the corresponding y value there is 6. So this is what I was explaining to say, to represent the coordinates of the turning point, this is where the x value is negative b over 2a. Do you guys agree that we used that formula to calculate the axis of
Yes, sir.
symmetry?
Yes, sir.
Okay, so now how did we get the y value? We said from that graph of G, let's say this is the graph of G. From that graph of G, wherever we saw x, this is G of x, remember. Wherever we saw x, we substituted that value that we got using this formula. Do you guys agree?
Sir.
Yes, sir.
So that is what I was explaining to say, generally, or the standard form of representing a turning point is this thing where we say the x value of the turning point, we know we get it using that formula, which is negative b over 2a. For us to get the y value, we substitute wherever we see x using that same value we got when we calculated the x value. So if this graph was the graph of f, then it means the turning points, the coordinates of the turning points are represented by f of, then you just change the name there to f. So that's why I'm saying don't worry that much about all of this. Just know that as soon as you get the axis of symmetry, you substitute on the original equation to get the corresponding y value. I hope that makes sense to everyone. So now let me explain something very, very much important. Is there someone who's got a question? So I assume there's no one who's got a question. Let's say this is the graph of y is equals to positive 2x squared, let's say plus 4x minus 5. So this is obviously y is equals to ax squared plus bx plus c. What I want to talk about, guys, is that c over there, which is that c over there. So the c value, it represents the y intercept. Remember, this is the turning point. You mustn't confuse it. This is the turning point of the graph. This is where the graph turns. But that one over there, it's represented by the c value on the graph, which means it's negative 5. So that means there is negative 5. What about another function maybe similar to that one, guys? So in this case, when you interpret this this graph, you're going to say, let's say this is the graph of h. So my graph of h is that one which is h of x, and this one, let's say, is the graph of f of x, and f of x is equals to, let's say, obviously said maybe negative 2, maybe plus 6x, and then obviously let's say plus 3. So ladies and gentlemen, for the graph of f, this is the turning point. I just explained to you how you calculate the turning point. So now I'm talking about that c value. The c value is that one where your graph touches the y-axis, which means is positive 3. Did that make sense to everyone, guys, before we move to the next part?
Yes, sir.
Yes, sir.
Okay, 100%. So now let's move to this part. Let me now explain this type of function where you've got ax squared is plus p plus q. Okay, so in this case, guys, your p and your q represents the turning points. So your p and your q represents the turning point. And obviously, your a value represents, or maybe tells us more about the shape. So it doesn't change. The a is about the shape. Obviously, if it's that, it's positive a. If it's that, it's negative a. But in terms of p and q, it tells us more about the turning point. So that means this is the x value of the turning point. This is the y value of the turning point. For example, if we've got y is equals to, let's say, it's 2x, let's say, plus 4, close squared, plus 9. So the a value already is positive, then it tells us we've got a smiling shape. So for you to calculate the turning points, that means you equate this to 0 for you to get the x-intercept. Then you take that as it is, not necessarily the x-intercept, but the axis of symmetry. So that means you're going to say x is equals to, or maybe let me say, I'm going to say something which is going to make it even more simple. So you equate this to 0, then you have x plus 4 is equals to 0, which means x is equals to negative 4. So your axis of symmetry is negative 4. So what I wanted to explain to you guys is that if you are given a function in that form, then for you to determine the TP, you write that in the opposite sign. What is the opposite sign of 4? It's -4. That one, you write it as it is, as 9. So guys, did that make sense, or should I give you the last example on that one?
Give it a last example.
One more
As the last
example,
example.
please.
Last example, sir.
Let's say we've got g of x is equals to, let's say in this case is positive 4 into x, let's say it's minus 1 squared, let's say it's minus 7 over there. So obviously we know our a value is positive. It means we're going to have that type of a shape. And then now in terms of your axis of symmetry, it's either two options. It's either you say x minus 1, which is that inside, you equate it to 0, then you solve for x. Obviously you transpose it, changes the sign, it becomes positive 1. But in terms of the q value, you take it as it is. Option number 2 is to say you write that value in the opposite sign and you write that one as it is. So what I mean by that, it means the turning point of that, you are going to have, let's say TP in the opposite sign. It's -1 there, then you write it as +1 inside the brackets. That one, the q value, take it as it is. So that means your axis of symmetry, that's where you've got x is equals to 1, and then your y value, you've got -7, which means your y-axis is going to be on this side, and your x-axis there. So x-axis, y-axis. So this is where you have +1, and then the y value is on the negative side, which is -7. So this is how you find this is how you find the turning points when you're given an equation in that format. So in this format, you don't say that q value is your y-intercept. The y-intercept is only if it's given in that format, which is the c value. But if it's given in this format, you only have your turning points. Guys, does it make sense to everyone so far?
Sir.
Yes, sir.
Yes, sir.
Okay, 100%. So now let's move to the next part of our notes. The next part is number, what is it? It's number 4. So this type of a function, you've got that one where you've got the negative a value. This is the turning point. So that point is what we call the maximum point. This is the maximum point. But if it's like that, then the turning point there is the minimum point. So you just need to know that if it's like that, then the turning point there is the minimum point. And if it's like that, the turning point there is the maximum point. Does it make sense, guys?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Then in short, it means on one graph, on one parabola, you can never have maximum and minimum. It's either you have maximum or you have minimum. So let's talk about number 5. So in terms of number 5, let's do it like that and say we've got something similar to that. This is x, this is y, and then let's say that value there, which is the turning point, let's say it's 5. So guys, every time when we talk about the domain, we refer to the x values. When we talk about the range, we refer to the y value. So the range is is the y value of the turning point. That is the range. So that means, can you see this graph? It stops there and then going down. Can you see? So that means for a said shape, if they want you to give the range, you are going to say y is less than whatever y value of the turning point. But if it's like that, so can you see it goes upwards, then you are going to say y is greater than whatever the y value of the turning point. So it depends if they said, or the sign there, they used greater than or is equals to, or otherwise they used less than or is equals to. For now, you just need to be aware of this information. You will understand it better when we solve the question. So in terms of the domains, that means you will comment on those x values if you know what they are for that graph. Otherwise, for this graph is going to be that one and that one. So you will understand it better as we solve the problem. So guys, did that also make sense to everyone?
Yes, sir.
Yes, sir.
Okay, so let's now
Yes,
move
sir.
to the last part of our notes, where I teach you how to plot this function, or how to sketch. So let's say how to sketch. So if you have access to that image that I sent in the group, we follow these steps. So let's say you are given the graph of f of x, which is equals to x squared minus 5x minus 6. Is there someone who wants to tell us what do you notice about that function in terms of A and C?
Six, sir.
Sorry, say again, Trias, can you come again?
6, sir.
Okay, 6. And the other one, anything that you want to comment about that function? Okay, assuming that you are not confident because we are doing this for the first time, it's fine. So show us, this is how you interpret it. So you say this is a parabola. Why? Because it has x squared. It's in that form of a quadratic equation. So I wanted you guys to say we've got a positive a value, which means we're going to have a smiling shape when we sketch. And again, we've got the y-intercept, which is a negative 6, which is negative 6. So this is what I wanted you guys to say with regards to that function. So that means when you draw your function, or when you sketch it, it mustn't have a sad shape. So let's follow the steps that I explained to you, or that I've done for you as part of the notes. So we said step number 1, you need to find the y-intercept. How do you find the y-intercept? Remember, if you want the y-intercept, then it means x is equals to 0. This is how you do it. So that means if you want the x-intercept, then y is equals to a 0. So these are the basics. I hope you fully know that. So just to explain so that it makes sense, if you've got a graph similar to that one, you know very well that this is the x-intercept. What does x-intercept mean? It means that's where your graph or your function touch the x-intercept. So you know very well that at that point where it touches the x-intercepts, that's where the x value you don't know, but you know your y value is 0 there because it's along that origin. Also there, you don't know the x value, but you know your y value is 0. So there, at that point, this is what we call the y-intercept. That's where your function, your f of x, touches the y-axis. So at that point, you know very well that x is 0, but you don't know what is your y value. That is why we say when you want, or when you're calculating the y-intercept, your x is 0. That we know. X-intercept, your y, it's 0. So that is where it is coming from. So guys, before I continue, did all of that make sense to everyone?
Yes, sir.
Okay, 100%. So now let's find the y-intercept. So that means where we see x, we substitute 0. Remember, f of x, guys, this is the same as y. That's why I'm going to say y is equals to, wherever I see x, I'm going to substitute 0. Minus 6. So that means 0 there, 0 there. The value that I'm going to get, I know this is 0, this is 0. I'm getting negative 6 already. So the second step is for you to find the x-intercept. That means that's where your y value is 0. So from that original equation, you say 0 because that's where y 0 is equals to x squared minus 5x minus 6. So this is the second step. So for you to find the x value, so remember guys, a parabola will have two intercepts. So that means you're going to have two values of x. So yes, that is why it's very, very much important that you know how to factorize. So this is where you factorize that equation. So you can either use Musa. If Musa is attending the lesson, just mention your name. I know you were going to use a quadratic equation, but because at this point in time, Sitla is not allowed to use it, he's going to use this in grade 10 and say x and x, then two values that when multiplied together they give you negative 6 is 3 and 2. The bigger number between these two takes the sign of the middle term. The sign of the middle term is negative. So for you to have negative 6 when you multiply this, that's if this one is positive 2. So that means you can equate this to 0, equate that to 0. So you're going to have x plus 2 is equals to 0, or x minus 3 is equals to 0. You solve for x, you transpose. This is negative 2. X is equals to transpose. This is equals to 3. So ladies and gentlemen, did that make sense to everyone?
Yes, sir.
Yes, sir.
Okay, so the next step, what you now need to do
Yes.
is to find a, what is it? According to our steps there is to determine the axis of symmetry. So this is negative 2 and 2. Just make sure that we don't lose all of that.
Sorry, sir, may I ask a question?
Mm-hmm.
I used x minus 6 equals to 0 or x plus 1 equals to 0. And when I multiply that, it gives me negative 6. And then when I add, it gives me negative 5.
Okay, let's check. Maybe I'm the one who made a mistake over there. I think you're y is equals to negative 5x minus 6. So let's factorize this one, guys. I think I'm the one who got it wrong over there. So you're saying you had 6 and 1. Yes. When you multiply, the bigger number takes the sign of the middle term.
Yes, sir.
Then for you to get negative 5, that's if you have a positive over there. Then you equate that to 0, that to 0. You end up having that, or you end up having that. This is correct. Ladies and gentlemen, did you understand what she said? Can you just mention your name? I'm sure some of you guys also noticed that part.
I'm Ovaya, sir.
Okay, so everyone who's in grade 10, Shreya, Stele, and Sitle, Do you guys see the danger of using your head to factorize? You can easily make a mistake. Do you notice, guys? Okay, so ladies and gentlemen, what I was explaining over there is that it's very dangerous to use your head to factorize because sometimes you get incorrect values. So that means if I continued with those incorrect values, we were not going to plot the correct graph. So are we all on the same page so far? Please make sure that if you don't understand, make sure which part you're not understanding so that we can explain it and be on the same page. Are we all on the same page so far?
Yes, sir.
Okay, 100%. So now what we need to do, our next step is to determine axis of symmetry. Obviously, we know our axis of symmetry, we said, is negative b over 2a, which is negative b there. It's minus 5 over 2. Our a value is 1. So what is that, guys? I think positive that. Then I think it's 5 over 2. Just confirm for me over there. So now that we've got our axis of symmetry, then we need to find the turning point. How do you find the turning point? Obviously, you know your x value is 5 over 2. What you need to do is to substitute this into the original equation where you see x. So that means y is equals to 5 over 2 squared minus 5, 5 over 2, minus 6. Then what is that one, guys? Is there anyone who got an answer for that one?
It's negative 59 over 4.
So you are getting negative 49 over 4. Is there someone to also confirm if that answer is correct?
Yes, sir. I'm also getting negative 49 over 4.
100%. So that means we now have the turning point, which is negative 49 over 4. So now that we have the turning point, this is all that we need, guys. So that means for you to be able to plot a parabola, you need the y intercept, you need the x-intercepts, you need the turning point, the x and the y of the turning point. So 1, 2, 3, these are the 3 stuff that you need. So now you can sketch, or let's say you can plot the points. So you can firstly start by having what is it, your Cartesian plane over there. So let's see, what is the y-intercept? Obviously it's negative 6, which means it's going to be on this side. What about our x values? So we're going to have an x value there, and let's say maybe 1, 2, 3, 4, 5, 6. We are also going to have another point there. What about the turning points? What is 5 over 2? I think this is 2.5. So it's 2.5. Then somewhere there we're going to have a turning points. What about the y value? Let's check in decimal. So this thing is the same as negative 12.25. That one is the same as 2.5. So that means somewhere down there where you've got negative 49 over 4. And then here you've got negative 1, you've got 6 there, and the y-intercept, let's say it's negative 6 somewhere there. And what is it? Your x value, which is the x of symmetry, is that point there. So this is going to be your turning point. So that means we have our x-axis as negative 1, as positive 6. We have our y-intercept, which is negative 6. And again, we have our turning points where we've got, what is it? It's 5 over 2. Then by freehand, you just join these lines. Then this is the turning point. This is where it turns. So this is the graph of F. So this is how you plot it. I'm not sure if it made sense to everyone, guys. Can you just indicate if that made sense to everyone?
Sir, understood it, sir.
It makes sense, sir.
Are you sure, guys, it made sense? Did it make sense to everyone? Remember, in case if you don't understand, you can just indicate so that we re-explain. Otherwise, remember this lesson is being recorded, so you can still catch up, watch the lesson again, and make sure that you understand. But so far, does it make sense to everyone? The other guys who are also in this lesson, I'm not able to see who is in the lesson, but does it make sense, guys?
It does make
Sir.
100%. So this is how they give you marks at marking center. So this is how they mark for this type of a question. They're going to give you a mark for you to identify the x-intercepts. And again, you are going to get a mark for indicating the y-intercept. And again, they are going to give you a mark for the shape of your graph. And lastly, they are going to give you a mark for your turning points. So ladies and gentlemen, this brings us to the end of our lesson for today. I just want to have an indication if you did enjoy today's lesson and there's no one who's left behind, because from here on our next lesson we'll be solving exam type of questions where I'll be teaching you in terms of how the questions are asked and again how you answer those questions. So for this type of problems, guys, I want you guys to get 80 and above. If maybe this question, the whole of it is allocated 10 marks, I want you guys to get 8 and above. So it doesn't matter whether you take full marks, but let's get 80% of this question. So guys, any indication, are you guys happy with today's lesson? And again, are you ready for next lesson where we solve exam question papers?
Yes, sir. I was happy with today's lesson, sir.
Super.
Who is it? Is it Lebohang? Are you having a question? No question. Okay, so guys, that brings us to the end of our lesson for today. Thanks very much. I will see you on tomorrow's lesson.
Thank you, sir. Bye, sir.
Thank you, sir.
Bye.
Sir,
You said bye, sir.
sir,
Is there someone who's got a question? Someone is calling.
No, sir, it's not a question. Sir, please invite me to any grade 10 geometry, especially Euclidean, sir.
Oh yes, with regards to geometry, I have to make time to study that chapter because when I did my matric, that chapter it was actually introduced a year after I completed my matric. So I haven't really studied that chapter, but I know most of you guys are having a big challenge with that chapter. So I think, let's say before, let me not make a timeline, but say I will make time to study that chapter and I'll make sure to teach it to you guys. Obviously, I'll need to start from grade 10, study 11 and 12. Then I'll do a lesson on geometry. So, is that fine, Larat?
Yes, sir, it's fine.
It's
Okay.
fine.
All right, 100%. So, guys, just there's only one thing that I need to mention. Remember, guys, I'm only having a chance to prepare for your for our lessons only between 7 until the lesson ends. From there, I won't be able to look at the book. So there's some, especially new learners who send via inbox some questions and everything. So guys, I won't be able to answer because during the day I'm at work. After work, that's when I prepare for a lesson. After the lesson, it's time to have some rest. So just make sure that if you are given a homework, homework, classwork, project, or whatever, you can just ask for a lesson that I've done where you can watch and answer those questions yourself. So you can imagine if I'm writing homeworks, whatever, for everyone. You are many, guys. I've got a lot of students. Not everyone is able to to attend my lessons. So if you are able to attend my lessons, you are lucky. But otherwise, don't be surprised when you send me something via inbox and I don't respond. I get a lot of those. So if I had to respond to everyone via inbox, I wasn't going to be even making these lessons. So I'm not sure if that makes sense to everyone, guys.
We understand, sir. It's okay.
Okay, thanks very much, Lebofam, for understanding. So, guys, have a very good night. See you in tomorrow's lesson.
Thank you, sir.